The height of a rider on a Ferris wheel is given by the function h of t equals 10 sine pi over 30 t minus 15 plus 12, where h of t is the height of the rider after t seconds after the rider gets on. Word problems are in radians, because word problems make no sense in degrees. Okay? So you're going to be in radian mode whenever you're touching a word problem, because it doesn't make sense in degrees. If you you know that a circle rotates every 360 degrees, right? Well, now they'll say we do one full rotation every 30 degrees. That doesn't make sense. You've been taught your entire lives that a circle rotates in 360 degrees. So it makes no sense to do these questions in degree mode. They need to be in radians. Okay? What we're first going to want to be able to do if we're given any type of equation, the hardest part is even if we want to punch it into our calculator, we can't get a window to fit it. Okay? There's really, 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 really easy ways to get you to fit a window to an equation. Okay? We're going to go through these pieces here that are going to help us get there. So it says, what are the maximum minimum heights of this wheel? How do I get max and min really quickly off of an equation? Nope. Start it like 3 times in your notes, which makes me believe you don't look at your notes. Actually, start it twice in 2 separate events, and I can remember exactly where it was. Your D value, which is your midline. If you go to your midline and you do what, will you get to your maximum? Add your amplitude. So if you take, to get your maximum, and I start this, and I'll start it again for the 3rd time. I did it the very first when we had A's and B's, horizontal stretches and vertical stretches. Then I did it again when I added C's and D's to make a point. Now I'm doing it again when I get to a word problem. So I'm hoping by the time I get to the test, this actually sticks. Okay, the maximum can be found really easily from your equation by taking your midline, the middle of your graph horizontally, and adding to it your amplitude. Someone said that and they were completely correct. How could you get your minimum then? Take your D value, which is your middle of your graph, and subtract your amplitude. Because where do your amplitudes meet at? At your midline, right? So really, really easy to get your max. So if you take your max, if you take your D plus your amplitude, you'll get your max. What's our D in this case? 12. What's our amplitude? Just disconnected, that's awesome. Plus 10. Oh, come on. Oh, great. And we get 22. That represents our X or our Y max, guys. Our Y max. As high as it goes. Then we take our minimum, and you guys told me it was D minus amplitude, which is completely correct. So it's 12 minus 10, which is 2, which is our Y or our X minimum. Our Y. So our Ferris wheel is rotating from 2 to 22, say meters. 2 to 22 meters, 2 to 22 meters, and throughout it'll be at a height, right? But if I asked you to tell me when they hit 27 meters, you're gonna be like, it ain't happening. This thing rotates from 2 to 22, 2 to 22, 2 to 22. Why not 0? What do Ferris wheels usually have? A base. Usually you walk up some stairs, get on a base, get onto the Ferris wheel so your legs don't break off when it goes around to the ground, right? Now, could a Ferris wheel actually be at 0? Absolutely, a Ferris wheel could be at 0. If you in like a gondola Ferris wheel, you could step into it and go around, your legs won't break off. Good things, right? So you have to look close to see exactly where this is. So now they could say, hey, at what height do you get on the Ferris wheel? You guys could be like 2. Do you have to punch in your calculator at all? No, they're just asking you for the minimum height. It's D minus amplitude. Very easy to answer. Right now, very easy to make my window. My Y part of my window, right? My Y min I'm going to make be below 2. My Y max I'm going to make be above 22. I usually go like 0 and 24. I make them a little bit more below and above so that I'm not just getting just the curve stuck, right? So if I go to my window, oh, I deleted my calculator. That's awesome. If you go to your window, make your Y min be 0 and your Y max be 24. And your Y scale could be 2 or 4 or whatever you want it to be. The Y scale isn't essential. It's just how many what each of your ticks are worth. Okay? Makes sense? And it's why, because what they say here, h of t is the height of the Ferris wheel. What are we talking about right now? The height of the Ferris wheel, right? So we know it's the y, because it correlates with h of t. Now, how long after the wheel is at its lowest point does it reach its highest point? We'll deal with that one in a second. We're going to go C first. How long does it take for the Ferris wheel to make one revolution? What is one revolution? What's that a fancy word for? The period, which of a plane circle usually is 360 degrees. But however, it may not take, it'll take you that long to get around, but we're talking time now, right? We're not talking degrees. So we want the period. The period we find by going 2 pi divided by b on where problems are always in radians. What's our b in this case? Pi over 30? So we're going to do 2 pi divided by pi over 30, which is actually 2 pi times 30 over pi. So it's 60. 60 what? They tell you what the units is for time. T seconds. So this thing rotates every 60 seconds. I often try and see 2 full rotations. So let's think about this. T is x, right? And x is time, is it not? What does time usually start at? 0. Could it start later? Sure. Could it start earlier? No, that's negative time. You're not going back in time. Okay? So just getting the period helps you get your x scale and your x max and x min. My x min I would make be 0 because time starts at 0. And I'd make my x max personally myself be 120 because I like seeing 2 full rotations, just in case they ask me something later. So I know that at least if I make my x max be 60, I'll see at least one full revolution of this Ferris wheel. Okay? So if I make it be 60, I'm going to see at least one full revolution. I'm going to make it be 120 so I can see 2. And then, I don't know, I make my x scale be 10 or be 30 or be 20, whatever you want it to be, what each tick is worth. Okay? Then press graph and you should be able to see your graph easily. You should be able to see 2 nice full revolutions. You should be able to see the min and the max. As long as your calculator's in what mode? Because you did everything in radian, right? So do you see a nice graph? Did you type it into your y equals? What I would hazard you to do, because this is why some people don't get it to show up, is this pi over 30 is a fraction. And the only way your calculator knows it's a fraction is if you put it in as a fraction, which means in brackets. Okay? If you don't put it in brackets, you're not going to get the same graph. Has everyone got it show up? This one says, during 1 minute of the ride, this way you have to get to show up, during 1 minute of the ride, so the very first time it rotates, right? Because the thing takes 60 seconds to rotate, which is 1 minute. At what times after the rider gets on the wheel are they at a height of 20 meters? Height of 20 meters. Is that X or Y? Did they give you X or Y? They gave us Y. So we know Y equals 20 meters, and we want to know what X is. Where's the only place we can plug in Y? And just the Y equals, right? So go to Y2 and put in 20. Don't put it in Y1. You've just taken out your sinusoidal function. You see nothing now. It's just not good. Okay, do you see it? Y equals 20. Did you put it into your Y2? How many times is it crossing right now? How many times is it crossing? It's crossing 4 on the screen that you have, but we're only going to give answers to the first 2 because they want it in the first 60 seconds, right? So how are we going to find those X values? Find the intersection. So second trace 5, enter, 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 and give me the X values. To 1 decimal. So I would have what is it, 10 sine pi divided by 30 x, I don't remember the rest. Oops. Yeah, we're good. Plus 12. And then the window was 0, 120, 0, 24. Weird, it doesn't work out. Why? I'm probably not in the right mode. Boom, 2 revolutions. Then we went to y equals and we put in a 20. I only care about this one and this one. I do not care about this one and this one because those are outside of 60. Second trace, 5. Get up onto the red. Enter, enter, enter. And I get 23.9. Second trace, 5. Enter, enter, enter. 36.1. I can't distinctly remember which one I was on. This is awesome. This is just guessing. Oh, there we go. Okay, so what were they? X equals 0.9 seconds. And now what if I said at what time? Nope. At 43 seconds. The rider's at what height? Yeah. So this time, did I give you X or Y? I gave you X. Where's the only place you can punch into X? Second, trace, value, and X equals pops up, and you're going to put in 43, enter. The table works if it's a whole number. If it's a decimal, you can't go to the table. Second, trace, value. And then that's your X equals. So your Y equals is Y equals. If you're given the X, you have to go second trace value, and it pulls up X equals. That's the only place you can pull it from. And then you do 43, enter. And you put in any X value there. And so he's at 14.1 meters. Done. Mm-hmm. Okay, go ahead to this one. So this one we're going to come up with an equation. I promise you, the easiest way to come up with an equation is to follow the steps I'm going to talk about. I always draw myself a circle, because no matter what, it's making a circle. That's the only way we're going to get a sine or cos graph is if it forms a circle. Yeah? I don't care. Moving ahead. So I draw a circle, and then I divide the circle into 4 pieces. Each of these 4 pieces are going to get me a coordinate, an XY coordinate. This one down here is going to give me 2. That's where I'm going to start. So here, we're going to fill in what we can about this drawing. Ferris wheel has a radius of 10 meters. What part of that circle is represented by 10? What part of the circle is the radius? Nope. What part of the physical part of the circle, distance from the center to the edge, is a radius? That is the definition. Okay, so I'm going to use it as the height, right? So I don't really, yes, it is 10 this way and this way, but I don't really care about it horizontally. I care about it this way. So it's going to be, the Ferris wheel has a radius of 10. So this is 10 here and this is 10 here, technically, meters. We agree? So some people will say, oh, well, this coordinate's 10 and this coordinate's 20 then. That is assuming that this Ferris wheel rotates right at the ground. So we should maybe read and see if it does. Could it? Yes, it could. Like I said, you could get into one of those that you're enclosed and totally it could spin around. So we have to read. So it says it rotates every 40 seconds. That's the period of it, right? That's how long it takes to do one full revolution. So we know that X is time and Y is height. We know that. That's how it always works, right? So at 0 seconds, we're at the bottom of this Ferris wheel. And then again at 40 seconds, we're at the bottom of this Ferris wheel, correct? Because it takes 40 seconds to rotate. We agree? How do I get the numbers in between? Divide 40 by 4 because I cut it into how many pieces? 4. So if I go 40 seconds divided by 4, each of these pieces are going to occur, each of the stops. Like if they stopped us every spot, it would be at 10 seconds. So here I'm at 0. I always go rotate counterclockwise. I don't know why. It's just the way I go. So 0, so 10 seconds. Then this would be 20 seconds. Then this would be 30 seconds. Then this would be back to 40. Right? And we could keep going forever and ever and ever and ever. But we're going to stop always with one full revolution. Now we need to be able to get the heights. We need the y's, right? We have all the x's. The x's are really easy. Once you get the period of it, just divide it by 4. This one says passengers get on the bottom, which is 1 meter above ground level. So is this baby at ground level? No. It's 1 meter above. So I'm going to draw myself a ground level. I'm going to draw a little bottom on it. And it's 1 meter from here to here, right? We agree? So what is the coordinate? This little coordinate down here, this blue one. It's 1, right? Not 0. These are 1s, are they not? Because we're giving the physical coordinate of that circle at that height, right? So what's this one then? 11. It's not 10. It's from ground to get here, right? So it's 11. Then what's this one? 21, because it's from ground all the way to get to here, so 21. Then what's this one? I think you said 11. Either that or you were scared. I'm not quite sure. Okay. So from here, we can actually come up the entire equation, every equation. So, what is the amplitude of this Ferris wheel? Remember the sinusoidal graph would start at 1, go up to 21, back down to 1, up to 21, back down to 1, up to 21, back down to 1, up to 20. That's all it's doing, right? Because the sinusoidal graph itself only actually encompasses the circle, does it not? Not the base, not above it. But you need the base in order to know where you start.